Have you ever heard someone say, lightning never strikes the same place twice? Maybe you've used that phrase yourself when talking about unlikely events or rare coincidences. But here's a question. Is it actually true? Can lightning really avoid hitting the same spot more than once? And if not, where did this popular saying even come from? The answer might surprise you. Not only is this common belief completely wrong, but understanding why reveals something fascinating about how lightning actually works. Today, we're uncovering the truth behind one of nature's most misunderstood phenomena and exploring why this myth has persisted for so long. Let's dive in right here on Simple Things of Time. Lightning is one of the most powerful forces in nature. A single bolt can carry over 1 billion volts of electricity and heat the air around it to temperatures 5 times hotter than the surface of the sun. It's dramatic, dangerous, and has captivated human imagination for thousands of years. But despite how common lightning is, there are about 100 strikes happening every single second around the world. We still have a lot of misconceptions about it. The idea that lightning never strikes the same place twice sounds logical at first. After all, lightning seems random and unpredictable. The chances of it hitting one specific spot seem incredibly slim, so hitting that exact same spot twice? That must be nearly impossible, right? Well, not exactly. In reality, lightning doesn't strike randomly at all. It follows very specific patterns based on the landscape, objects, and atmospheric conditions around it. To understand why, we need to talk about how lightning actually forms. Lightning happens when electrical charges build up inside storm clouds. Ice particles colliding within the cloud create a separation of positive and negative charges. The negative charges typically gather at the bottom of the cloud, while positive charges collect at the top. This creates an enormous electrical field, kind of like a giant battery in the sky. When the electrical difference between the cloud and the ground becomes strong enough, the air, which normally acts as an insulator, breaks down. The electricity finds a path to the ground, and that's when we see a lightning strike. But here's the key detail. Electricity always takes the path of least resistance. It doesn't just strike anywhere, it targets the easiest route to the ground. What creates the easiest path? Tall objects, conductive materials, and isolated points that stick up above the surrounding landscape. That's why lightning tends to hit things like tall buildings, towers, trees on hilltops, and metal structures. These objects essentially reach up toward the charged clouds, making the distance the electricity has to travel through the air shorter and the path more attractive. Now here's where it gets interesting. If a location has features that make it a good target for lightning once, those same features don't disappear after the first strike. A tall tree is still a tall tree. A metal tower is still a metal tower. The highest point in an open field remains the highest point. That's why lightning absolutely can and does strike the same place multiple times, sometimes even during the same storm. Let's look at some real-world examples. The Empire State Building in New York City gets struck by lightning about 25 times every single year. During one particularly intense storm, it was struck 8 times in just 24 minutes. The building's height, metal frame, and position make it an irresistible target for electrical discharge. Or consider the famous Christ the Redeemer statue in Rio de Janeiro. Standing 98 feet tall on top of a mountain, it's hit by lightning multiple times every year. In 2014, during a powerful storm, lightning struck it so many times that it actually damaged the statue's fingers and had to be repaired. Then there are natural landmarks. Park rangers at Yellowstone National Park have documented certain tall trees being struck year after year, sometimes multiple times in a single season. Lightning doesn't care that it hit that tree before. The tree is still tall, still isolated, and still the best conductor in the area. So if lightning clearly does strike the same place twice, where did the myth come from? Historians believe the saying likely originated as a figure of speech rather than a scientific observation. It was meant to express the idea that extremely rare or unlikely events won't repeat themselves in exactly the same way. It was never supposed to be taken literally. The phrase appears in various forms across different cultures and has been used in literature for centuries. It became popular because it's catchy, memorable, and seems to make intuitive sense. People saw lightning as such a random and powerful force that the odds of it hitting the exact same spot seemed impossibly small. Without understanding the science, the myth stuck. There's also a psychological element at play. When lightning strikes, it's dramatic and memorable. But most of the time, we don't witness the same location being struck repeatedly. We see one strike, and then we move on. We don't stand around watching that same tree or building through multiple storms, so our personal experience reinforces the idea that lightning is a one-time event for any given location. The truth is, predictable patterns in nature often defy our intuitions. Lightning seeks out the path of least resistance every single time, which means certain locations are essentially magnets for strikes. In fact, lightning protection systems are designed around this very principle. Benjamin Franklin discovered this in the 18th century when he invented the lightning rod. His brilliant insight was that if you place a tall, pointed metal rod on top of a building and connect it to the ground with a wire, you can intentionally attract lightning and safely channel its energy into the earth. The rod gets struck instead of the building, protecting the structure from damage. Modern skyscrapers, towers, and important structures all use lightning protection systems based on Franklin's design. These systems work because they deliberately create the path of least resistance, practically guaranteeing that lightning will strike them over and over again. Engineers count on lightning striking the same place multiple times. It's not a matter of if, but when and how often. Even in nature, there are spots that seem to attract lightning more than anywhere else on Earth. Lake Maracaibo in Venezuela holds the world record for lightning activity. There's a unique weather phenomenon there called the Catatumbo lightning, where storms produce lightning almost 300 nights per year, with strikes occurring up to 280 times per hour. The same area, the same atmospheric conditions, and yes, the same places getting struck again and again. But there's also something poetic about this truth. The fact that lightning can strike the same place twice reminds us that nature follows patterns and laws even when it seems chaotic. There's order in the storm. The same forces that guide a river to flow downhill or a plant to grow toward the sun also guide lightning to follow the most efficient path. Understanding this doesn't make lightning any less awesome or powerful. If anything, it makes it more fascinating. Every time we see a bolt tear across the sky, we're watching physics in action, electricity finding its way home through the path of least resistance, following rules that have existed since the beginning of time. So the next time someone tells you that lightning never strikes the same place twice, you can share the truth. Not only can it happen, but it happens all the time. From the Empire State Building to trees in your local park, from communication towers to mountain peaks, lightning strikes the same places over and over because those places give it exactly what it's looking for, the easiest path to the ground. The myth may persist in our language and our culture, but the reality is far more interesting. It's a reminder that common sayings don't always reflect scientific truth, and that questioning what we think we know can lead to fascinating discoveries. If you enjoyed this video, don't forget to like, subscribe, and stay tuned for more stories about our fascinating world. Alright, that's all for now. Thank you for watching.